Hi, this is lesson 10.3 in accelerated geometry. It's called Applications of the Pythagorean Theorem. So you're not going to learn anything new. You're just going to apply everything that you've learned so far to some word problems. One problem that this author likes a lot is the kind where he's putting something in a box. So in this case, it says a specially designed bat was made for the author of the book, and he wants to send this bat somewhere, so he wants to know what is the smallest box that could be used to ship the bat. So look at how cool this bat is. It has Discovering Geometry on it, the title of our textbook. Pretty cool. Okay, so here's an example of how you could solve a problem like that. What is the longest stick that will fit inside a 24 by 30 by 18 inch box? So they have the picture there. It says you can lay a stick with length D diagonally at the bottom of the box. So that's what they have over here. They said, okay, we could lay it down there. But if you tilt it, you can position an even longer stick with a length X along the diagonal of the box as shown. So I could tilt it up so it is actually up there. So the question is, how long could that stick X be? So I look at it and I say, what if I put in this line here? Look what I have, a nice, beautiful yellow right triangle. But in that yellow right triangle, the leg is 18, this longer leg is D, and the hypotenuse is X. So 18 squared plus D squared equals X squared. I can't solve anything like that because I have two unknown letters. But now, what if, I'm going to change the color of my marker here, what if I look down here? There's another right triangle in this drawing. Right there is the right angle. The leg is 24, this leg is 30, and the hypotenuse is D. So I can find out what D is by using the Pythagorean theorem on the bottom green triangle. And once I know what D is, then I can use it with the Pythagorean theorem in the yellow triangle. So here is the first part, the green triangle, 30 on this side, 24 on this side, so 30 squared plus 24 squared equals D squared. 30 squared is 900, 24 squared is 576. When they add those together, they have D squared is equal to 1,476. Now, they don't go further and say, let's take the square root of both sides to find out what D is, because they're looking ahead to the yellow triangle. And in the yellow triangle, you're going to use D squared. 18 squared plus D squared is equal to X squared. So they say, okay, let's just leave that as D squared. All right, so there we have D squared plus 18 squared is equal to X squared. And the D squared is 1,476 plus 18 squared is equal to X squared. Then in the next step, they do 18 squared is 324. When they add those together, they get 1,800 is equal to that X squared. And then when they take the square root of both sides, X is equal to 24.4. And so the longest possible stick is about 24.4 inches. Okay, this example, find the perimeter of an equilateral triangle whose median measures 6 centimeters. So here's the whole problem, and what I did first is I created just the equilateral triangle. And I knew that in an equilateral triangle, this angle is 60, and this angle is 60, and this angle here is 60, but the median comes right from that vertex to the midpoint of the opposite side, and in an equilateral triangle, that median is the same thing as an angle bisector and an altitude. So if it's an angle bisector, that 60 becomes 30 over here, and this is a 90, and if I use the 180 degrees in a triangle, or the fact that this is right here 60, I have a 30, 60, 90 degree triangle. Okay. On this side also, a 30 and a 60 over here, and a 90 degree triangle. So what do I know about this 30, 60, 90 degree triangle? The side across from the 30, so there's 30, the side across from it is A, The hypotenuse is 2a, and the side across from the 60 over here would be a square root of 3. So now I look. A is, I don't know. 2a is, I don't know. But a square root of 3, it is 6. So I take a square root of 3 is 6, and I write it down. Now I have to solve for a. So I divide both sides by the square root of 3, and I get a equals 6 over the square root of 3. You can't leave the square root of 3 in the denominator, so you rationalize it, which means you multiply the bottom by the square root of 3, and to be fair, you multiply the top by the square root of 3. Okay, in the next step, I have 6 square root of 3, and on the bottom, the square root of 3 times the square root of 3 is 3, and then I can cancel the 3 and the 6, divide them both by 3, and I get 2 square root of 3. So a is 2 square root of 3, so that's this piece here, but I want the whole side if I want the perimeter. So that would be twice that. So one side would be 4 square root of 3, and the other side is 4 square root of 3, and the other side is 4 square root of 3, so 3 times 4 square root of 3 gives me an answer of 12 square root of 3. And one more left. Closing question. At a local community college, the area between the buildings is a 120 meter by 120 meter square-shaped grassy area. To accommodate the way students walk across the area, the school is going to put in a sidewalk on a diagonal going across the square. To the nearest meter, how long will the sidewalk be? So here is the square, 120 by 120, and they said they're going to go and make a sidewalk along the diagonal. So if these two legs are equal in this right triangle, then this is a 45, 45, 90 degree triangle. And if it's a 45, 45, 90, I know the legs are each L, and the hypotenuse is L square root of 2. So what do I know in here? L square root of 2 equals, I don't know. But L equals 120. So I come up here and I say, okay, L is equal to 120. So now, if I want to find L square root of 2, I substitute in an L here for 120, or 120 for L, I should probably say. And I have L square root of 2 is equal to 120 square root of 2. Put that in my calculator, I get this long decimal, which they round to 170 meters. So that is the lesson for applying the Pythagorean theorem. So good luck with your homework problems. Please contact me if you have difficulties. Hope everything is well. Hope you're safe. Hope you're happy. Hope you're healthy. Bye.